Hello, I'm Seema and welcome to part 2 of the chapter Chemical Reactions and Equations. In part 1, I told you about chemical changes and physical changes. I gave you the example where we took salt and water, and I told you that this is a physical change because the substances, they maintain their identity, they do not change. And in a chemical reaction, the substances, whatever is reacting, they change their properties and new substances are formed. I also told you that we have chemical reactions occurring around us all the time. Now the question is, if we look at a change, how can we tell whether that change is chemical or is it physical? So how do we identify a chemical reaction when we see a change occurring around us? We can do so, and there are 5 characteristic things that you can observe and that are sure shot giveaways that okay, this is a chemical change. And what are these 5? We call them the characteristics of chemical reactions. When a chemical reaction is occurring, these are the characteristics or things that you have to look for to identify a chemical change. These 5 characteristics are: usually whenever a chemical reaction occurs, it results in the evolution of a gas, formation of a precipitate, a change in color, a change in temperature, or a change in state. So any one of these characteristics, if you observe, or a combination of these, you get a hint that this is a chemical change that is occurring. Now I will deal with each one of these one by one. And if you look at the board as I have displayed it, in your textbook, the equations are not given in this form. It is given in the form of language. And I have this practice of writing down the equations, especially the simpler ones. The more complex or the very complex ones I have not written. But these simpler equations, if they are written for the student and they keep passing from in front of your eyes, slowly you get used to them, and sometimes you simply by reading about it and by learning about it in an informal way, you learn the equations as well. It is somewhat like, when little kids, they are shown alphabets in the park. And they are playing on the swings and all, and they are going on swing number A, they're going on swing number B, or they're climbing the rocks, and the rocks are given alphabet names. They automatically learn the alphabets. It is somewhat like this. Chemistry should not be difficult to learn. It should not be a task. It should just come by to you easily. Of course, it will not be as easy as going on the swings, but still, if you see these formulae, if you see these equations time and again when you're studying, they will automatically grow on you, and it will make it much easier for you to learn them. So that is why I have written these equations, some of them, and some that are more complex, I have avoided those because at this level I do not want to scare you away. So let us begin. What are the 5 characteristics? The first one is the evolution of a gas. If you see a change occurring somewhere, you are out in the park or maybe in the mall, and all of a sudden you see there's something that's happening and smoke starts coming out of it. It means that a gas is coming out of that. And if that gas makes you uncomfortable, or if it's a lot of gas, that definitely is a chemical reaction, one. Secondly, if it is a gas that is making you uncomfortable, run from there because you don't know what chemical reaction is occurring there. Jokes apart, whenever a gas is given out, it is an indication that the change or the reaction that is taking place, it is a chemical reaction. We have this conical flask, and we take zinc granules in it. It's just an example. If you take a few zinc granules, zinc is a metal, and you take granules of zinc and you pour dilute sulfuric acid over the zinc granules, and we just sit and we observe. We observe bubbles of air coming out of the sulfuric acid. The liquid is covering the zinc granules, which was the solid granules, and we find that bubbles of a gas, they are evolved. This gas that comes out is actually hydrogen gas. And since you see those bubbles, it's an indication that this is a chemical change. I've written this in the form of an equation. You have zinc and you add sulfuric acid. The formula for sulfuric acid is H2SO4, zinc is Zn. It gives you zinc sulfate and hydrogen gas. This arrow upwards means it's a gas. So a gas is evolved, and the evolution of a gas is an indication that the change that we are talking of is a chemical change. Another such example is when you have sodium carbonate and you mix it with hydrochloric acid. You have sodium carbonate in one beaker and you take hydrochloric acid in the other beaker and you start mixing them. When you start mixing them, it results in the formation of sodium chloride. It results in the formation of water. Sodium chloride is nothing but common salt. Water, of course, will only add to the solution because the solution is already in water. So the water just, you do not observe it. But what do you observe here? And the sodium chloride, the common salt that is formed, is soluble. So it dissolves. You don't see that either. What you see is carbon dioxide. Carbon dioxide is a gas and you start seeing the bubbles coming out. The bubbles are of carbon dioxide, and that again is an indication that this change that occurred is a chemical change. And how do we know, whether it's a... Okay, we'll come to that part later. How do we identify what gas is given out? There are tests to carry out and find out which gas is evolved, whether it's hydrogen or is it carbon dioxide. In the case of hydrogen, if you carry out this reaction in a small test tube and you bring a burning flame close to the test tube, the hydrogen, the test tube starts burning like a candle because hydrogen is a combustible gas. Carbon dioxide, on the other hand, is a fire extinguisher. So if you bring a burning flame close to the test tube, mouth of the test tube, the carbon dioxide is going to extinguish the flame. Right? So they are just, ways how you could make it more interesting and learn which gas is being given out. Also, if you allow this carbon dioxide to pass through lime water is calcium hydroxide. It turns the lime water milky. It makes it milky in color, like it turns white. We'll do all these details as we study further. But right now you need to focus that whenever a gas is evolved, it means a chemical reaction is occurring. Next is formation of a precipitate. To understand a precipitate, first let us see what types of salts do we have. I told you the sodium chloride, that is common salt, if you add it in water and you dissolve it in water, do you see the sodium chloride separately or it just dissolves? It just dissolves. You do not see the sodium chloride. So we say sodium chloride is a soluble salt. There can be substances which are insoluble. And if they are insoluble, what happens when you have something that is insoluble? It settles down at the bottom of the beaker. Let us say I have sand and water, and I try to dissolve the sand in water. The sand will settle down at the bottom because the sand does not dissolve in water like salt. A precipitate is actually nothing but an insoluble substance. But when we talk of a chemical reaction, we say we have reactants and we have products. When you have an insoluble product, that product settles down, and that product which is insoluble in the water or whatever medium you're carrying out your reaction in, that product is known as a precipitate. So how would we define a precipitate? A precipitate is an insoluble product. It is not a reactant. It is when the reaction takes place, whatever is formed, that new substance that is formed, this new substance which is known as the product should be insoluble in water. So if it is insoluble in water, you just are carrying out a chemical change. You took two substances, you mixed them, and they were both soluble in water. They appear to be clear solutions. And when you mix them, you realize that all of a sudden there's something that is being formed and which is settling down at the bottom. It means the nature of the substances that you mixed has changed. A new substance has been formed, and this new substance is insoluble in water. So what does that mean? That the reaction that took place was a chemical reaction. Now, examples here are that you take potassium iodide, K is potassium. Potassium iodide, when you mix it with lead nitrate solution, both of these are clear solutions, and you mix them, they are colorless, clear. It results in the formation of potassium iodide, and potassium iodide is yellow in color. Potassium iodide is yellow in color, and potassium nitrate is formed, which is colorless. So it is yellow in color. Secondly, it settles down at the bottom. So we had colorless solutions. When we mixed them, it resulted in the formation of a color, and that colorful substance settled down at the bottom. So we find that the formation of a precipitate, an insoluble product was formed. Therefore, this is a chemical change. I'm not focusing on the yellow. I'll come to it in the next step. Here we have barium chloride and sulfuric acid. When you mix barium chloride and sulfuric acid, it results in the formation of a white precipitate, white powder, which settles down at the bottom. It is the white precipitate of barium sulfate, which is white in color. And how do we show a precipitate in a chemical reaction? We show it by an arrow pointing downwards. Did you notice? A gas was an arrow pointing upwards, which means when gases are formed, they bubble and they go upwards. But when a precipitate is formed, it goes down and it settles down at the bottom of the beaker or the test tube. So precipitates are represented by arrows pointing downwards. So evolution of a gas or the formation of a precipitate are evidence that the reaction is a chemical reaction. The next thing is when you see a change in color. A change in color is also an indication that a chemical change occurred. Now, in this example here, these were colorless, but when we mixed the two together, we got a yellow precipitate. The color of the solution changed and we got a substance which was a precipitate, and the color also changed. So there are two indicators or two characteristics which are shown here by this particular reaction. That is why I used a star here. It resulted in the formation of a precipitate, and the next characteristic, that is the change in the color of the solution. So change in color and the formation of precipitate. There were two indicators here that this change is a chemical change. An example of a change in color is if you take any acid, like citric acid, you could take acetic acid. I've written citric acid, I've not written the formula because it's a little complex and I don't want to scare you away. When you mix it with potassium permanganate, the potassium permanganate solution is a purple colored solution. So you take citric acid in one test tube and you take potassium permanganate solution in the other test tube. And you start pouring the citric acid in the test tube containing potassium permanganate, which is purple in color. And you keep adding to it. And what do we notice? As we keep adding the citric acid to the purple colored potassium permanganate solution, the purple color starts vanishing and you get a colorless solution. So what has happened here? It has resulted in the change in color. And this change in color is because a chemical change occurred. There is one such change that I observe very commonly. Hydrangeas are one of my favorite flowers, Hydrangeas, I have a bunch of hydrangeas here. They are blue in color and they are also found to be pink in color. And the blue colored hydrangeas, if you notice, the color of the hydrangea flower that you obtain, you can change the blue hydrangea to a pink hydrangea. How can you do it? If your soil in which you've planted it is acidic in nature, you will get blue flowers. But if you put a base in it, for example lime, if you add lime to it, lime is calcium oxide, and when you put water over it, it turns into calcium hydroxide, and calcium hydroxide is basic in nature. So when you put lime in your soil and you start watering it, the lime goes into the roots, and the basic nature of lime, it turns the color of the hydrangea from blue to pink. So every year when you get your hydrangeas, you can change the color by changing the chemical that you add to the soil. Isn't it interesting? And what is happening? This is also the change in the color of the blooms that you get is also an indication of how chemical reactions affect our normal life. So a change in color is an indication of a chemical reaction that occurs. What is the next characteristic? A change in temperature. You must have noticed that if you have ever seen someone whitewashing something, they add quicklime, that is lime. Lime is also called quicklime, and it is actually calcium oxide. If you take calcium oxide, that is lime, it is commonly called tuna. And if you add water to it, we find that as soon as you add water to it, it starts swishing. There's a sound that comes. The moment you add water to it, it starts making a sound. And when it starts making a sound, it makes a solution. The solution is slaked lime. It is calcium hydroxide. I just told you we can change the color of hydrangeas with the same reaction. We can add the calcium oxide a little bit around the plant and add water, because you have to water the plant. It turns into calcium hydroxide, which is basic in nature. And when you carry out this reaction in a beaker, you take a little bit of lime and a little bit of water and you're carrying it out, and you hear that it suddenly changes into calcium hydroxide. The beaker becomes hot. It becomes really hot. So much that you can observe, you may feel the temperature change with your fingers if you're touching it. When reactions occur, some reactions involve the release of heat, and some reactions require absorbing heat. So when a reaction is occurring in a beaker and it is giving out heat, we call it an exothermic reaction. Exo means exit, going out. Heat is going out of the reaction. So this reaction where you have quicklime and water, it gives out heat, and since it gives out heat, the beaker which is surrounding the reaction mixture, it becomes hot. So it is giving heat to the surroundings. It is an exothermic reaction. So when chemical reactions occur, they can lead to a release of heat. That kind of a reaction is known as an exothermic reaction. And some reactions involve absorption of heat. So exiting is exothermic, and endo, coming in, come indoors. So that reaction where heat is coming in is known as an endothermic reaction. So come indoors. That's just a hint to remember what an endothermic reaction is and what an exothermic reaction is. So some reactions involve the absorption of heat. If they absorb heat, where are they absorbing the heat from? They are absorbing the heat from the surrounding. So if you have a reaction which is endothermic in a beaker, the beaker will turn cold. Why? Because it absorbed its heat from the beaker, from the air, from the surroundings. So the surroundings become cooler. So we find that reactions, they can be exothermic or endothermic. Examples are the quicklime. When it reacts with water, it results in the formation of slaked lime and it makes the beaker warmer. It means the reaction is exothermic, and it is an indication that this is a chemical change. Also, we did this example here, zinc and sulfuric acid. I put the star here again to show you that this is a reaction which has two characteristics. Zinc combines with sulfuric acid to form zinc sulfate and hydrogen gas. So it is a chemical change. The indicator is evolution of a gas. And the second is that this reaction also leads to the warming up of the beaker, which means it is an exothermic reaction. So change in temperature is also an indication that this is a chemical change. And barium hydroxide combines with ammonium chloride to result in the formation of barium chloride and ammonia and water. And barium hydroxide combines with, and this one is an endothermic reaction. This is an endothermic reaction. It results in the beaker turning cold. I have missed one example here. This is an example of change in color. You have potassium dichromate solution, and potassium dichromate combines with sulfur dioxide, and this potassium dichromate is acidified, and acids have H positive ions. So since it is acidified and you can use any acid, we just write H positive in it. It results in the formation of chromium ion, which is green in color. So whatever product is formed here will have the chromium Cr3 positive ion, and which will have a green color. So what happened? Potassium dichromate solution, which was orange in color, when you acidify it and make it react with sulfur dioxide gas, it results in the formation of a green compound. And the color changes from orange to green. So this is also an indication of the change in color, and therefore it is a chemical change. Again, this reaction is slightly more complex for your level. but no harm just looking at it. You don't have to memorize it. All you need to learn is the names and the colors. So you could do that. You could have, while I'm speaking, you could have a pen and a paper just to write down the names, or you could see your textbook to refer to these reactions and get the names of the compounds that we are talking of. But I would always suggest keep the equations in front of you, because as you keep looking at them, you would not even know when you learned them. So the change in temperature we've discussed. So we've now done 4 characteristics: evolution of gas, formation of precipitate, change in color, change in temperature, and now we come to the 5th and the final characteristic of chemical reactions. That is a change in state. The physical state of the substance changes. Now, I told you that when you burn anything, like when you're burning a candle, what is burning there is actually the wax. Wax is the fuel. So when you're burning wax, what happens? Whenever you burn wax, wax is basically a product of petroleum, and it is made up of carbon, hydrogen and oxygen. The molecules are made up of carbon and hydrogen mainly, and oxygen. If when it is burning, the oxygen is available from the surroundings. So when burning of wax occurs, it results in the formation of water and carbon dioxide, water vapor actually. And if you really look at this, wax was a solid. The water vapor which was formed, if you condense it and bring it to room temperature, it will turn into a liquid. And the carbon dioxide gas which is formed is evolved, it bubbles out, or it escapes as smoke. So what happened? The products, the state of the substance changed from solid to liquid to gas. So any change where you see that the physical state of the substance itself is changing because of, and you can turn ice into water, you can turn water into water vapor. That is not a chemical change. That's a physical change. You're only increasing the temperature and the physical state of one substance is changing. But when you have a reaction in which you have 2 or more substances reacting and then there is a change in the physical state, that is when we say a chemical change has occurred. So these were the characteristics of chemical changes. And if you found the video helpful, please give it a thumbs up. Subscribe to my channel, recommend it to all your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.